So this is our laser pointer design. The laser pointer consists of two sources. One is the mic, another is the aux. The mic source is coming from here. You have a mic setup here, the 4.5 volt source going to the resistor, going to mic, and going to ground. And you'll take the signal from here. And the signal coming here is a DC plus AC signal. What we're going to do is to use a capacitor filter out a DC signal, so only pure AC is going to be amplified by the inverting op-amp. The inverting op-amp has something like this structure. So the source is going to a resistor and going to the negative part. Then it will be a feedback loop with the output and negative side. The gain of this op-amp will be negative of RF over RN. In this design, RF will be the potentiometer and the RN will be our 55 ohms resistor. So the other source is the aux. Aux is a pure AC signal coming from a device, and this is very pure, so we don't need to filter it like this one. We only have to make it amplified with the inverting op-amp, so it's coming from here. The next step will be to combine two sources with a summing op-amp. The summing op-amp will take two sources with a resistor going to the negative side. The summing op-amp will be feedbacked with a resistor here. I place a potentiometer here so you can adjust the gain. The gain will be mostly defined by this potentiometer. Then we will have a signal ready to the laser pointer. However, the laser pointer will require a higher voltage value in order to turn on. To do so, we will have a bias T construction. So this is our bias T configuration. You will have a signal here passing through a capacitor. So this is a pure AC signal. You have a pure DC signal coming from here and going through an inductor. Only pure DC signal will pass the inductor. Then the DC signal cannot flow back because of this capacitor. So the signal will combine with pure AC signal here and pure DC signal here, becoming a pure signal that can be sent out by the laser pointer. This is our receiver design. Our receiver has a photodiode here to sense the laser pointer signal. The signal will be filtered by the capacitor and amplified by an inverting op-amp. The inverting op-amp has a gain of 100. You have a 1K here and 100K here. So the inverting op-amp will give a 100 times of gain. So at this point, the signal voltage is enough to turn on the speaker, but the current might not be enough. To fix this problem, we have a parallel buffers to separate the signal and combine the signal again. So the voltage here and the signal here doesn't change, but you have a more current passing through. You will have enough current and enough voltage to turn on the speaker. So this is our actual circuit looks like. You have a mic here going to the inverting op-amp. You have an aux signal here going to the inverting op-amp. You combine these two signals going to the summing op-amp. Then you have this signal going to the bias T, and it's ready for the laser pointer. This is our receiver circuit. So you have a photodiode here, a capacitor to filter the photodiode signal, and you're going to an inverting op-amp. Then you have a parallel buffer to make a more current passing through, and you have a speaker here. So aux is sending the signal. The laser pointer is able to send the signal. So far, the receiver doesn't function perfectly, but our transmitter works perfectly fine during the demo and during the lab.